Hey, what's up guys, welcome to my YouTube channel. Today I have chosen one of the very interesting elementary topic, which is gravity. And in this video I want to focus on what happens to gravity when we reach at the center of the earth. Probably when I was in high school or in middle school, when I saw the Newton's law of gravity, I was quite obvious that when we reach at the center of the earth, it is very simple that when we follow the inverse square law, it just becomes infinite. But the result turns out to be very different from what I thought. So guys, if you are along my path, just wait for the answer because I want to reveal at the end of this video. So just keep watching. Newton came up with the law so-called the universal law of gravitation, which stated that every particle in the universe is attracted with a force such that it is directly proportional to the product of the masses and inversely proportional to the square of the distances between them. This formula is very important and it precisely determines the orbits that the cosmos takes and the observed trajectories of the meteorites. The universal law of gravitation given by Newton cannot determine some of the observed phenomena in the cosmos. Gravitational force, one of the four fundamental forces which makes up the universe, was studied seriously by Isaac Newton when he wondered when apples fall, does moon also fall? And then it made him to discover another era of mathematics, which is the calculus. Later, his study about the gravitational force was taken into different account by Einstein in 1915, where he came up with the general theory of relativity, which is the geometrical representation of how gravity works. But the law given by the Newton cannot determine some of the observed phenomena in our solar system, like the orbital recession of Mercury. Therefore, there was a need of some the better theory of gravity, which Einstein took a step forward, and in his general theory of relativity, it could precisely determine the orbital recession of the Mercury. It became one of the greatest revolutions in the history. The influence of the gravity is inevitable, like the boulder falling from the cliff and falling of the broken prayer flags, the falling of the apple and the moon revolving around the earth, the motion of the entire planet around the sun, and the motion of the whole galaxy are under the influence of gravity. Okay, let's now do a small calculation here. First, the denotation. From Newton's law of gravitation, what we get is the gravitational pull of the two body is g m1 m2 by d square, where d is the distance between the masses of the body 1 and 2, which is m1 and m2. So let us apply same analogy here in the diagram. Here there are four locations of the body: location 1, location 2, location 3 and location 4. So the body of location 1 is located at the distance of RA from the center of the earth, which is the radius of the earth, where the body at the location 2 is located at the distance at the height of h from surface of the earth and from center of the earth, which is at the distance of RA plus h. And the body 3 is located inside the earth by the distance of d. Therefore, the distance between the center and the body 3 is r minus d, and location 4 is located at the center of the earth. Here, r minus d equals to 0. So, with the above understanding, we came up with the denotations of capital D. At position 1, d equals to RA. At position 2, d equals to RA plus h. At position 3, capital D equals to RA minus d. And at position 4, d equals to 0 or RA minus D equals to 0. Now let us find the magnitude of gravitational force between the body at different positions and the earth. At position 1, we know that the capital D is just equal to radius of the earth. From Newton's law of gravity, we have Fg equal to Gm1 m2 by d square. Writing this equation in terms of the conditions here, we get Fg equals to G m me by Ra square. So this is the magnitude of gravity at the position 1, which is on the surface of the earth. Now next, at the position 2, we know that the D equals to Ra plus h, which Ra is the radius of the earth and h is the height of the position at which the body 2 is located. Therefore, the distance between the center of the earth and the position 2 is Ra plus h. Now rewriting the universal law of gravitation according to this condition, we have Fg equals to G m me by Ra plus h the whole square. This is the magnitude of the gravity at the height of h above the surface of the earth. Now if we plot the above result in the graph below, we will get it gradually decreases as the height increases. Now at the position 3, the distance d equals to Ra minus d. Here we need to have different approach. First, let us compute the mass of the earth. Considering that the density of the earth is same throughout the surface, we have density of the earth is just equal to mass of the earth divided by the volume of the earth. And here we should also consider that earth being the perfect sphere. Here we know that the volume of the sphere is given by 4 by 3 pi r cube. Here we can write volume of the earth is just equal to 4 by 3 pi of Ra cube. Here in the diagram of the position 3, we should draw the inner sphere extending from the body, which the center radius is just r minus d. Therefore, we can modify the volume of the earth at the position 3 by Ve equals to 4 by 3 pi Ra minus d the whole cube, which is at position 3. Now putting this volume of the earth in above equation, we will get the expression for mass of the earth as Me equals to density of the earth times 4 by 3 pi Ra minus d whole cube. Now rewriting this above equation in universal law of gravitation, we will get Fg equals to G m rho e 4 by 3 pi Ra minus d the whole cube divided by d equals to Ra minus d the whole square. Therefore, simplifying above equation, we get at the position of 3 as Fg is just equal to 4 by 3 G rho e pi m Ra by d. This is the value of the gravity at the position 3, assuming that the density of the Earth is distributed evenly across the surface. At the position 4, we can simply use the equation that we derived in position 3, which is 4 by 3 g rho e pi m Ra minus d. Here we know that Ra minus d equals to 0. The whole above equation just turns out to be 0. Therefore, at the center of the Earth, the magnitude of gravity is just equal to 0, which is not infinity. So if I plot this result in the graph, it is observed that when we go beyond the surface of the Earth, the gravitational force decreases linearly, which is like this, and drops to 0 at the center of the Earth.